Bismillahirrahmanirrahim. How are you, students? Today we will do the numericals, lecture number 11. Open your books, page 49. The magnitude of dot and cross product of two vectors. This is the magnitude of dot product and this is the magnitude of cross product. A dot B is equal to 6 under root 3 and A cross B is equal to 6. So A dot B is equal to AB cos theta and A cross B is equal to AB sin theta. Divide AB cos sin theta, divide this equation with this one, equation 2 by equation 1, we will get this relation. This is cancelled, so and sin theta divided by cos theta is equal to tangent theta will be equal to 1 divided by under root 3. So theta is equal to tangent inverse this value. We will get the value. Now, a load of 10 Newton is suspended from a clothes line. The distance the line so that it makes an angle of 15 degree with the horizontal at each end. Find the tension in the string. This is W, this is theta. We will use the equation then find the tension. T is equal to W divided by sine theta, or W divided by 2 sine theta. We already derived this formula in class 9th. So T is equal to use this relation, do it. Home assignment. It is very easy. Four coplanar forces act on a body at a point Q as shown in the diagram. Force F1 makes 0 degree. Force F1 is 20 Newton. F2 is 100. F3 is 110 and 160 F4. Making an angle of 0 degree, 45 degree, 30 degree and 20 degree. So we will make coordinate axes. This have only x component, but you will do the process for x and y both. This vector f4 have negative y component and negative x component. F2 have positive x component and negative y component. So find the horizontal component f1 cos theta, f2 cos theta, f3 cos theta, f4 cos theta. So different forces, different angle. It is f2, it is theta 3. So this is theta 3, this is theta 4. It is negative because its x and y component are both fourth. It is in fourth quadrant, third quadrant. So vertical component will be negative. Horizontal and vertical both will be negative. If you take first quadrant, both component x component and y component will be positive. If this vector is in the second quadrant, y is positive, x component is negative. With third quadrant, y is negative, x is negative. If fourth quadrant, x is positive, y is negative. This is the way of calculation. Use this formula, find the horizontal component, and this formula to find the vertical component. Vertical component of f1 is f1 sine theta 1. If 2y is equal to 2 sine theta 2. f3y is equal to e3 sine theta 3, and f4y is equal to e4 sine theta 4. Now these calculations have been written. It means it is f4 is in f4 is here in third quadrant, so y component will be negative and x both will be negative in third quadrant. Now, a force of 5 Newton is applied perpendicular to the plane of a uniform door 2 meter high and 0.6 meter wide. Find the torque about the line joining the hinge. Joining the hinge. This is force, this is momentum, and theta is 90. So torque is equal to R cross F is equal to RF sine theta. Now the next numerical is difficult. If you remain successful in making the proper data, you will do it. Otherwise, it will make to difficult to this numerical is difficult to get a solution. To get a solution, it is very difficult. So focus on the data. Find the magnitude of the force provided by the support A and B. We have to find tension, the upward force F1 and F2. F1 and F2. If it's shown a balanced condition, weight of the plane is 500 and it is uniform in shape. Weight of the block is 100, block and student is 100 and 500 respectively. This is weight of block, this is weight of student. So 1 W1 W2 and weight of the rod is 100. So upward force is equal to downward force. So you will apply the first condition, F1, if T1 or T2 or F1, F2, whatever you given the name to these forces. If one apply first condition and then apply the second condition, you will solve it. According to first condition, upward force is equal to downward force. You will get this equation. F1 plus F2 is equal to 1100 meters, and that is the answer. You can further solve. You can, if you want to solve it further, you can do it. Then by applying the second condition, three forces are acting on a body as shown in the figure. Find the magnitude of their resultant. Force F1, Fx, Fy, and Fz. Find the magnitude of the forces. So apply this formula, you will get the solution. A meter rule is supported on a knife edge placed at 40 centimeter. It is balanced at this point, 40 centimeter. It is found that the meter rule balance horizontally when a mass m 0.45 meter is attached 15 centimeter. From this point to this point, the distance is 15 centimeter, 0.15 meter. So weight is W1 and BC is suspended at 15 centimeter graduation as shown in figure. 15 centimeter graduation is shown in figure. So I will erase it because it is balanced at 40 centimeter. Okay, 0.5 is here, 15 centimeter from end A. So if it is 15 centimeter, it is 40. So this is 40. So this will be 25 centimeter. 40 minus 15 is equal to 25 centimeter. So 0.25 meter. is the moment arm of this. Distance between point of rotation and point of application. If the weight of the ruler is 0.9, it is acting at 50, calculate the position. It is acting at 50 centimeter. Uniform ruler, so it will be at 50 centimeter. Actually, it is not the exact, its length must be equal. This length and this length must be equal. Diagrammatically mistake. It is 0.10 meter, 10 centimeter. So it is on next page. So moment arm of this is 0.10 centimeter. Now torque 1 is equal to F is W1 DC. You will find this produce clockwise torque, so it is clockwise torque. Now we will find anti-clockwise torque. Clockwise torque is equal to anti-clockwise torque. So W2 CD DC W1. It produce clockwise torque, it produce anti-clockwise torque. It produce anti-clockwise torque. So calculate the moment about the knife edge in this balanced condition of the force due to the mass of the ruler. So apply clockwise torque is equal to anti-clockwise torque. So you will get it 52 point. Position of center of gravity must be this. Position of center of gravity must be this. Read the question and then listen again. A meter rule is supported on a knife edge placed at 40 centimeters. It is found that the meter rule balances horizontally when a mass which has a weight of this 0.45 Newton is suspended at the 15 centimeter graduation as shown in the diagram. Calculate the moment about the knife edge in this balanced condition of the force due to the mass of the ruler. If the weight of the ruler is 0.90, calculate the position of the center of gravity. Calculate the moment about the knife edge in this balanced condition. The force due to mass of the ruler. See again. A meter rule is supported on a knife edge 40 centimeter. It is balanced at 40 centimeter. It is found that the meter rule balances horizontally when a mass which has a weight 0.45 Newton is suspended 15 centimeter from end A. Calculate the moment about the knife edge in this balanced condition. In this balanced condition, calculate the position of its center of gravity. Okay. First, you should find the torque produced by this. Produced at 40 centimeters by this. First, you should find torque, and we find it. Applying the second condition of equilibrium, clockwise torque is equal to anti-clockwise torque. So you will apply the second condition and you will find the equilibrium position. First, you have to find torque and then you have to find position of center of gravity, which is this one. A uniform plank AB of length 4 meter. Length of plank is 4 meter. 500 is suspended by vertical loop at the end A. Here the 500 weight is acting. A girl of weight 300 Newton standing at a distance of 1.2 meter from end A This distance is 1.2 meter. Calculate the tension in the rope suspended at the end B. We have to find this tension. You can find both the values, this one and this one. First condition is T1 plus T2 upward force is equal to downward force 500 plus 300. This is downward. The Planck weight is at the midpoint, so it is also in the downward direction. So upward force is equal to the downward force. And the second is that you are objective. You are interested only to find this value. If you are interested to find this value, to understand, find both the values. To only solve the numerical, take this value only. And it is take rotation about this point. So it produces anti-clockwise torque. So T cross 4, T cross 4, which is in this case T cross AB written. And this produce clockwise torque, this also produce clockwise torque. It will be subtracted because clockwise torque and anti-clockwise torque both are in opposite direction. Both are in opposite direction. So this and this. It is 1.2, it is 2 meter, and it is 4 meter. You will get this value. It is 1.2, and this is 500, which is a 2 meter midpoint, and it is 4 meter. The diagram below shows the plane view of a door. If a man applies a force of 40 Newton, how much force is applied? 40 Newton. Calculate the moment of this force at A. What is the minimum force X must be applied at A in order to stop the door from the turning? So first, there is, let's say, a door. I'm taking this is, let's say, point A. This distance is 1.8 meter. Here the force is applied. Force is applied of 40 Newton. So torque is equal to Rf sine theta. So 1.8 multiplied by 40. 1.8 multiplied by 40. You will get the answer. This is R. You will find this answer. Minimum force at C. We have to find the minimum force at this point. This distance is 1.2. 1.2. So apply the second condition of equilibrium. Clockwise torque is equal to anti-clockwise torque. So 72 is equal to 1.2, and if X is the amount of force, so X is equal to 72 divided by 1.2. We will do it. Consider a ladder 200 Newton resting against a smooth wall such that it makes an angle of 60 degrees with the horizontal. Find the reaction of the ladder on the ladder due to wall and ground. First, weight is 200 Newton. So this is 200 Newton, making an angle of 60 degree. This angle is 60 degree. The reaction of the wall on the ladder is R1. This is R1 and this reaction is R2. So first R1 cross sine theta and minus W 1 divided by R1 sine theta minus W2 1 divided by 2 cos theta is equal to this. R1 sine theta written here and this is written here. You will get R1. Go back. Now look at the diagram. This is wall and this is ladder. Weight is acting at this point. This is called R1. So point of rotation is this. So this distance is equal to the length of total length of ladder. Total length of ladder. So cos theta R1. This is theta. This is perpendicular and this is base. So this should be considered base. This should be considered base. So 1 sine 60. 1 sine 60 R1 into 1 sine 60. And here it produce anti-clockwise star. So half of the length is considered. Half of the length is considered. So 1 divided by 2 cos theta. 1 divided by 2 cos theta. So here half of length is considered. So 1 divided by 2 cos theta. Yeah, L divided by cos theta. And it is L sine theta. So L is cancelled. Don't consider L. Take it 1 sine theta and 1 divided by 2. Half of the length is considered. So you will use this formula and will solve it. Now come to next portion. Since the reaction of the ground is R2 is equal to 200 Newton. Now find the resultant will be the sum of R1 minus plus R2 square. Resultant vector will be the sum of the two vectors. It is plus. We will get this way. Again. This is R1. This is R1. This is 60 degree, 90 degree, and this one is 30 degree. Now 200 weight is acting in the downward direction. 200 weight. So upward force will be equal to downward force. W is equal to R2 and is equal to 200. So this reaction is 200 Newton. Simply. Reaction of the wall is in this direction. So we take rotation about this point. It will be R1. This is the moment arm. This is the moment arm which is equal to the length of this side. Length of this side. So R1 into length is equal to L sine theta. Here it is L sine theta. And this is our the weight producer anti-clockwise rotation, clockwise rotation. So it will be half of the length of the ladder, half of the length of the ladder. So 1 divided by 2, 1 divided by 2, W into 1 by 2, L by 2, length of ladder cos 60 is equal to R1 L sine theta. This is cancelled, length is cancelled. So R1 is equal to 200, which is weight, cos 60 divided by sine 60. You will get the value R1. We finished this chapter. Thank you, students. When the proper class is started, so any deficiency, we will complete it. So thank you, students. If anything is left, you can ask me on WhatsApp. WhatsApp me the question, I will give you a reply. And wish you best of luck. Thank you, students.